on Monday. They're not difficult problems. Well, they're difficult if you don't know how to do them, right? That's true for everything. So I'm going to go over a few of these problems just to give you a bump in the right direction. This first one, I think this was number 1, actually, on your OpenStax. Anybody confirm that? Have y'all started looking at it? Is this number 1? Huh? This is number 5? Okay, well, whatever. It's on your OpenStax. This one, you have this circuit with this switch, and the reason I'm showing it to you is because we haven't really seen a circuit exactly like this, so we work problems exactly like this. What this switch does is it goes back and forth. It'll go over here, and then it'll go over here. So when it's over here, this circuit is on. And when it's over here, this circuit is on. So you have 2 separate circuits. When one's on, the other is off. And the figure's not drawn real well for that, but that's what you're dealing with. And also, there is a mistake. Instead of 20, this should be 2. I don't know why it says 20, but it should be 2. So make sure that you use that. And I'm doing this on a video. I'll post it onto YouTube and send it out to y'all to remind you. So you need to do 2 things. The first thing that you do is you think about this circuit. All right, that it's charging. And you just need to know what is the total charge on that 2 microfarad capacitor. We've done that, right? It's easy peasy to find the charge. I have a 10-volt battery and a 2 microfarad capacitor. What's my total charge? And then you switch over to the other side. And now this circuit is discharging. And that's really what the problem is asking about, is what happens in this discharging circuit. Okay, I want to know at t equal 4.5 microseconds, what is the charge on that capacitor, on that 2 microfarad capacitor. And we've done that. It's just a capacitor with a certain amount of charge, which we found it charged with a 10-volt battery. And then what is the charge after 4.5 microseconds? That's where you do the Q is equal to Q e to the minus t over RC. Okay? So that's that one. Again, there was a mistake here. This capacitor should be 2 microfarads. You first deal with the left-hand side, then you deal with the right-hand side. Now, the second one, this is a little more complicated, but it's not beyond your ability. I want to show you the steps. I'm not going to go through them, but I'm going to tell you about the steps. In this problem, it tells us that the ammeter measures 0.4 amps. So right off the bat, we get a lot of information. That I2 is equal to 0.4 amps. That helps us a lot because we now know what that current is. But we don't know what this resistor is. I want to find out what that resistor is. There are 3 steps that you need to take in this. First, you need to find I1. That's your first step. Your second step is you need to find I3. And then your third step, you want to find R. To find I1, you're going to use the loop rule. Which loop are you going to use to find I1? The left loop, the right loop, or the big loop? You're going to use the left loop. The left loop is the easiest one to find I1. You could also potentially use the big loop, but it's more complicated because you don't know what R is. Or you don't know what I3 is. But once you find I1, you can find I3. Which of Kirchhoff's rules are you going to use to find I3? The junction rule. Very good. So because you know what I1 and I2 is, I3 is almost trivial to find. So you'll find I3 with the junction rule. And then you'll find R. Once you know all the currents, it becomes fairly straightforward to find R through the loop rule. And with that, you can use the big loop or the right loop. You can't use the left loop because that wouldn't even have R in it. But you can use the big loop or the right loop. It doesn't matter. Okay? All right, so that's the second one I wanted to look at. And then there's this one about you want to take a picture of a bullet. It's like you have a strobe light, and you have to set that strobe light to go at a certain rate, and you want to know what that rate is. And so the first thing you want to do is how much time does the light need to be on? And it tells you here that you have 1 millimeter of motion at 500 meters per second. So given that rate of speed and that distance, I can find the time from last semester. Time is distance over speed, and so I can calculate what is the characteristic time of this flashing circuit. And then this time constant, it says it's okay for that time constant to be equal to that time. So then once you get that, it's just finding out what resistance will give you that time constant. Remember time constant, R times C? Okay? So really the tricky part here is figuring out what's the time. There are some other good problems on there, and certainly you'll see some of those problems on the test after spring break. It's the Wednesday after spring break. We have next week. Is it a full week next week? Well, we have all week next week. Oh, good. Oh, boy. I thought that we just had 2 days next week. But then the next week we have 2 days. Good. Okay, good. Then we're all right. Okay? All right. I'll post this video.